Nobody is paying attention. This thing is happening in the background while people bicker about politics. And underneath it all is this rising tsunami that, if we're not careful, is going to wipe us all out.
The goal of creating artificial intelligence was for them to become gods, to create a collective mind, a global computer that sees all, sees everything, to create an all-seeing eye.
The use of neural interfacing and physiological interfacing through the idea of remote-controlled small-scale systems to create a nanoswarm of biopenetrable materials that you cannot see, that can penetrate biochemical filters, that are able to integrate themselves through a variety of membranes, mucous membranes, and wherever, mouth, nose, ears, eyes, and they can be done in such a level that their presence is almost impossible to detect, and as such, the attribution becomes exceedingly difficult to demonstrate. The idea here is to read and write into the brain function in real time, remotely. What this has now done is put the brain literally at our fingertips of investigation, parting the proverbial curtains of the vagaries of what the structures and functions of the brain may do, but also parting those curtains of capability to allow us to literally go in up to the elbows to be able to assess, affect, manipulate, and control the brain.
Rather than hardware and software, they're actually going to a new form of software, and that is the biological replacement of the human brain, functioning as a quantum computer biologically, and then loading people, integrating people into this new form of brain.
There will be a virtual version of your brain as far as data is concerned, of what molecules, what chemicals, and whatever make up the actual physical brain. That data could be stored in the computer.
And that model would have the same input-output behavior as the original. So,
if our brains are connected to the internet, and if our brains are all connected, I could literally go into your head and see through your eyes.
As a result of being programs in virtual reality, the agents had the ability to take over the simulated body of any human that was a part of the Matrix, converting it into a copy of their own. If that body was killed, or an agent needed to change its location quickly, it would simply take on the shell of another human that was hardwired to the Matrix in a matter of seconds.
So Google was set up 18, 19 years ago to build a giant artificial supercomputer based on the neuron activities of the hive mind of humanity, with billions of people wired into it with the Internet of Things. And so all of our thoughts go into it.
Everything you think, from your feeling of self to the feeling that you may have a soul to your preference for cilantro or not, all of those things live inside a place which is dark and small and never sees the outside world.
In 2006, and the Sentient World Simulation, SWS, went live in 2007, which represents every person on the planet within this computer matrix as a node, and every node is given an avatar, an identifier. And that is real-time, 24/7 monitoring of every person on the planet. This is primarily, but not exclusively, facilitated by the adiabatic quantum computers produced by D-Wave Corporation. The adiabatic quantum computer is linked to 7 billion human brains. It is now, in its own language of cryptology, able to function independent of any oversight throughout the world with its own form of communication, its own form of code. And it is able to link everyone on the planet at this point.
And what we are trying to do is to use this precious knowledge to build machines that can actually create, manipulate, and use these parallel realities in the service of this one. We want to grab those parallel realities from this abstract space in which they live and crunch them down into this chip.
And you start thinking about us being the qubits in some massive, giant quantum computing simulation. It's almost as if they're either trying to harness or to recreate what is commonly referred to as a collective consciousness.
It's an engineered thing which has become a nexus point for all of these parallel realities. The shadows of all of these different universes intersect at a physical point inside of one of those boxes. You can think of it as a portal to all of these other alternate possibilities.
What did we think the year 2020 would look like 40 years ago? The future we dreamed of bears little resemblance to our present. We were supposed to have flying cars and robot maids. What happened? Have we failed? Or have we found something better? Artificial intelligence has fascinated us ever since scientists first taught computers how to solve simple problems. But ever since then, the promise of AI has been dampened by its limitations.
The field of artificial intelligence began in the 1950s, when computer scientists were thinking about how to use these new machines called computers to do things that we would consider intelligent, like playing chess or translating languages. What followed was the AI winter, when there was a great disillusionment with AI. There was a lot of excitement and enthusiasm about the possibilities for that in those days. People actually greatly overestimated how quickly progress would be made. Then in the early 2000s, we began the beginning of what is now machine learning, where there have been an amazingly rapid amount of progress and successes in the last few years. There is certainly a goal and a vision of having machines that can be perhaps someday as intelligent as people or even more intelligent.
30, 40 years ago, the people who actually programmed computers were computer scientists. And today you don't see them much around. They had white clothes and it was a clean room with big IBM's machines. And today you don't need that because somebody built the tools that allows everybody to do that.
For the last 60 years, people have predicted that human-level artificial intelligence would be about 20 years in the future. It's always 20 years from now whenever you ask the question.
Usually when you hear people speak about AI, the first thing that pops into their head is the Terminator and Skynet. The AI is coming to get you. We have no idea how to build a self-aware AI. So it's a bit overhyped that there's gonna be this self-aware sentient that is making decisions for you and taking over everything. We know how to build very simple machines that make simple decisions.
Today's AI is really machine learning. This is an approach where you gather lots and lots of data and you crush it together and you come out with pretty compelling outputs.
Machine learning is the branch of artificial intelligence that says, rather than trying to program very detailed rules for everything we want a program to do, let's create programs that can learn from their own experience. It certainly doesn't eliminate the need for humans to write the programs, but it greatly reduces the painstaking effort needed.
It's no longer engineers writing code, for example, to detect objects in a video. It's the data that is writing the code.
I'll give you a simple example, right? Let's say I want to build a machine that identifies cats. I give it an image and it needs to tell me, is there a cat in that image? How do you write the rules of how you identify a cat? You take a lot of images with cats, a lot of images without cat. And every time you feed it an image with cat, it learns something, and every time you feed it an image without the cat, it learns another thing. If you're doing it enough times, the machine suddenly understands what makes a cat a cat. And it's kind of magical.
As systems get better at processing data and making decisions, AI will expand into more and more roles. If the machines are getting better at our jobs, what does that mean for us?
A lot of people are talking about automation, and the assumption is that it's scary or there's a lot of downside. But in every part of our history where you've had technological innovation, there's always been an actual displacement. Sometimes it's of previous technology, sometimes it's people who have worked on that technology. And so while there's always a concern, especially through increased automation and efficiency, that people or jobs might be displaced, I think we have to also think about what the upside is, that there can be new technologies, new ways of doing things that can absolutely benefit us.
Every single time in the past, when technologies have taken away human jobs, more jobs have eventually been created than were eliminated. An example of that historically would be the printing press. The printing press eliminated jobs for scribes who used to spend their days copying books by hand. But by making it so dramatically cheaper and easier to copy text, the printing press enabled vast numbers of new jobs. In some sense, it created the whole publishing industry. So I think the same thing is likely to happen with new technologies.
As AI becomes ubiquitous, so does the potential for an explosion of new opportunities for all of us. But barriers remain. So what are some startups doing to address these challenges?
One of the things that we allow our customers to do is run a lot of experiments. When you build a machine and you take the data and you build that deep neural network, and the neural network starts to absorb the data, you have no way to know what would be the end result. So what we do at Missing Link is basically we automate the whole process of building AI. We have the privilege to see some of the most amazing things that our customers are able to do with our technology.
The technologies that we are developing over here are algorithms and software enabling even the simplest devices to have AI and machine learning. We are trying to make something small a little better. A robot to be more interactive, to save us more time, to be able to reduce number of accidents, and then to create a better life, safer life for everyone.
About in that all of the AI resources now are pretty much in the hands of companies and defense industries.
Quite a lot.
That have their own agenda for it, which is, what did you say? Killing,
selling, spying, killing, and gambling. Yeah. All the good stuff in life, right?
You say that with a smile, but it upsets you.
I mean, day by day, I'm enjoying life, right? And what's disturbing is this is all being done by 99% really good people, right? Like the people working at Google, I know a lot of them. Good-hearted people, they're trying to make a sustainable business, right? And, you know, I worked in DC for 9 years doing AI consulting for various intelligence agencies in Washington. And, you know, the amount of nasty terrorist plots that are squashed by US intelligence agencies is amazing. Like so many lives are being saved by the various three-letter agencies in Washington. And almost everyone I knew there has a really noble attitude, and you know they believe they're saving civilization from destruction. So it's mostly good-hearted people trying to do good for the world, but yet the way society is organized, the way governments and corporations have emerged to be organized
through capitalism.
Yeah, through however you want to describe the modern oligarchic world economic order, right? I mean, it's large international corporations cooperating with governments. I think of it more as corporate socialism than competitive capitalism.
Okay, why do you call it that?
Well, because large corporations largely control the laws of large countries, right? And so if the laws of countries are being modified so as to make life easier for multinational corporations, then in a way, it's a kind of socialism, but the benefit is for corporations more than for people, right? Right. I mean, the vision of capitalism as a sort of level playing field where companies are competing in a meritocracy, it's not really what you see in the world. Particularly if something like mobile, there's a limited amount of bandwidth. Who gets the bandwidth? Well, that's determined by government in cooperation with big companies, right? I mean, the internet, who sets regulations for the internet, right? So I think things are so cross-connected now that it's not like a fruit market out in the street or something where you have some free market and competition. Right. You have humongous companies with trillions of dollars.
Well, they're now monopolies and oligopolies, right?
Yeah, so and they have a lot of lobbyists, and they're getting politicians elected, and they're sculpting the laws. And I mean, in some ways, it works incredibly well, right? And I think there are some things these big companies do great, like the mobile phone or something, right? A little startup isn't going to make that at the present time. It's really hard. You have all these different pieces. They have to be built by different subcontractors, right? So, I mean, large corporations certainly have their place, and you know, intelligence organizations have their place because there are psychotic people out there, and there are nasty organizations that want to kill a lot of people, and that's sort of how the human brain works, right?
So the good-hearted people, smart people, developing this AI, but they're doing it for a lot of times the wrong reasons, and therefore
because of the way society is organized, right? It's the incentive structure, and you know, there's the whole question in the U.S. of whether corporations are people, and that's a legal question, but it's also sort of a philosophical question, because a corporation in a way is its own organism, right? Like, no one controls it. If the CEO or the board try to direct it in the wrong way, they can get thrown out somehow, right? And so it's its own organism, and they're sort of like parasites on humanity in a way, that are directing humanity in certain ways. And I think, but there are opposing dynamics also, right? So, and the internet is quite fascinating that way, because the internet is not owned by anyone, it's not controlled by anyone. Because of that, like, Iran is still on the internet in spite of all these crazy international sanctions. Mobile developed in more of a corporate way, and you can think about, like, if the internet had developed like mobile has, and every time you went from one country to another, you'd have to pay some insanely high roaming fee just to use the internet, right? But it didn't, right? Now, BitTorrent, largely used for illegal purposes, but it's interesting, like it got rid of huge companies. It disrupted industries quite rapidly through enabling file sharers. And, you know, for academic publication, academic publishers are going to be mostly obsoleted by Sci-Hub and LibGen and like peer-to-peer sharing of scientific books and papers. So these sorts of things show that there's a peer-to-peer decentralized mode of interaction
that gives you hope.
Can have a disruptive power. And Linux you can look at similarly, right? I mean, Linux, open source. I had a lot of arguments about that in the 80s. People are like, that'll never succeed because people need to be paid to do their work, blah, blah, blah. Well, you know, what happened is open source it interpenetrated with the capitalist economy. A lot of people are paid to work on open source software, right? But open source has huge advantages, right? And I mean, that's enabled the whole robot hacker ecosystem to come about through Raspberry Pi and other Linux-based maker kits. You know, you have Android is running on Linux, and because of that, you know, if the U.S. government goes apeshit and says like Huawei can't use Android anymore, well, most of it's open source. Huawei can use most of it. They just have to put a different layer on top of the base of Linux, which is in their phones, right? So I mean, and most servers on the internet are running Linux, which means that, you know, Iran, North Korea, China, anywhere can run all the servers using Linux. So it gets you away from corporate politics, it gets you away from intergovernmental politics, right? So we see things like Linux, BitTorrent, Sci-Hub, LibGen, now Bitcoin and Ethereum and the whole crypto economy.
Yeah, let's talk about that.
Internet, so all these are peer-to-peer things which are owned by everyone and no one. And so this is one dynamic, whereas the increasing centralization and oligopolization is a different dynamic. Both of these are being enabled and encouraged by computing and communication technologies, and they're in like co-opetition with each other, right? They're opposed, but yet they're also supporting each other in various ways.